Welcome everyone. Through this video, I am going to discuss different method of solving differential equation. In the previous class, I have discussed how to form differential equation, what is solution. Now today, I will discuss different method of solving differential equation. So number one, method of separation of variables. So suppose 1 plus x square into dy plus 1 plus y square into dx equals to 0. So this is differential equation because it involves derivative or differential. This is differential. So look, 1 plus x square, it is odd in terms of dy. So it is also odd in terms of x. So we divide throughout by 1 plus x square into 1 plus y square. So dy by 1 plus y square, dx by 1 plus x square equals to 0. Now look, here variables are separated. Now we can integrate. So integrating, we get this. Now integration of this is tan inverse y. This is tan inverse x. This is first order differential equation. So general solution will contain one arbitrary constant. Take one arbitrary constant to the left or right. So suppose this is C. So which is general solution? Which is general solution? Now this arbitrary constant C, it can be taken as tan inverse C also. Tan inverse C also. Because if we take tan inverse C, then we can simplify it. So what is the simplification? Tan inverse x plus tan inverse y. So x plus y by 1 minus xy equals to C, which is general solution. So you must put one arbitrary constant to left or right hand side. So which is general solution. So what is the method? So in this method, the given integral, in this method, the given differential equation can be put in the form. In this method, the equation can be put in the form f1x dx plus f1y dy equals to 0. So this is f1y, 1 by 1 plus y square, f1y into dy, 1 by 1 plus x square, f1x into dx. So integrating, we get general solution. So this is the method. Now we solve some problem by this method. Now we try to solve some problems by separation of variables. Now look, problem number 5. dy by dx into tan y sin x plus y plus sin x minus y. So look, if it is in this form, we cannot separate the variable because it is in plus form. So we use formula of sin c plus sin d. So tan y dy dx. So sin c plus sin d. So 2 sin x cos y. 2 sin x cos y. Sin a plus b by 2 cos a minus this. So tan y dy equals to 2 sin x cos y into dx. Now we separate the variable. So this is odd variable cos y. So divide by cos y. So tan y by cos y into dy equals to 2 sin x dx. So tan y by cos y. So sin y by cos y. So this is tan y by cos y. So sin y by cos y. So this equals to, this implies after this, tan y sec y, tan y sec y dy equals to 2 sin x dx. Now variables are separated, we can integrate them. So what is tan y sec y? This is sec y, and this is 2 cos x minus c. We must put integration constant to any of the side, which is general solution. So separation of variable. Now this is 5. So problem number 3. So they are of same type, very simple. You need idea of basic integration only. So cos y dy. So look, after this is cos y dy by dx. So e to the power x into e to the power sin x square into e to the power sin y. So look, e to the power sin x, sin, this is e to the power sin y. You correct it, sin y, this is sin y. So e to the power sin y is common, e to the power x plus x square. So cos y dy by dx. Now we separate the variable. So cos y by e to the power sin y into dy equals to e to the power x into x square into dx. So here variables are separated. Now you have to integrate this one. So sin y, derivative of sin y is cos y. So let sin y equals to z. So cos y dy equals to dz. So after this is cos y dy is dz. So e to the power minus z dz equals to e to the power x plus x square into dx. So this is e to the power minus z of minus 1. It is e to the power x, x cubed by 3 plus c. So e to the power x plus x cubed by 3 plus e to the power minus, what is z? Z is sin y plus c equals to 0, which is general solution. So separate the variable, then integrate. So this is method of separation. You solve the rest of the problems. Next, method of substitution. Suppose dy dx equals to tan x plus y. Now if we write dy by tan x plus y equals to dx, so variables are not separated. Here it is given in this form x plus y argument. So initially it cannot be expressed with the help of separation of variable. So we put a transformation, that is substitution. So let x plus y equals to z. So 1 plus dy dx equals to dz dx. So what is dy dx? Dz dx minus 1. So call it 1 and this is 2. So from 1 and 2, you look, what is dy dx? Dz dx minus 1 equals to tan z. So dz by dx 1 plus tan z. Now we can separate the variable. So look, now variables are separated. Dz by this equals to dx. So putting some suitable transformation, the differential equation can be reduced to the process of separation of variable. So take integration. So this is cos z by sin z plus cos z equals to dx. Now this is well-known integration of indefinite integral. So trigonometric integration. So we can express it in terms of denominator, cos z minus sin z by cos z plus sin z dz equals to dx. I have already stated, to solve differential equation you need idea of indefinite integration. So this cancel, 1 plus cos z minus sin z by cos z plus sin z into dz equals to dx. So if we take cos z plus sin z as p, so what is derivative of cos z? Cos z is minus sin z is cos z. So derivative of the denominator is numerator. So it will be log. So or log cos z plus sin z equals to p. So cos z minus sin z into dz equals to dp. So if we put this, so here we get 1 plus dp by p, 1. So we can write this dz. This is dp by p equals to integration dx. That is z plus log p equals to x plus c. So what is z? Z equals to x plus y. This is log. What is p? Cos z plus sin z. Cos z plus sin z equals to x plus c. So look here, cos z to cos z. So but you have to balance it by half. So you can write this as half, and here it is half of, or you can write this equals to 2x plus 2c. So y minus x, 2x transferred to left hand side, log cos x plus y sin x plus y equals to c dashed. You must put one constant to right hand side, 2c equals to c dash, so which is general solution. So initially tan dy dx tan x plus y, initially we cannot separate the variable, but putting some transformation, that is x plus y equals to z, it can be transformed into separation of variable. Now we solve some problems by separation of by substitution method. So consider problem number 2. Exactly same. So look, x plus y equals to z. Problem number 3, x plus y equals to z. Problem number 4, x plus y plus 1 equals to z. So seeing the problem, it is obvious that which transformation you have to put. So suppose problem number 2. So this is 1. So let z equals to x plus y. So dz dx, 1 plus dy dx. So dy dx equals to dz by dx minus 1. So call it 2. So from 1 and 2, so what we are getting? dz by dx minus 1, sin z plus cos z. So dz dx equals to 1 plus sin z plus cos z. So dz by 1 plus sin z plus cos z equals to dx. Now variables are separated. Now it reduces to the problem of integration. So it is trigonometric integration. So we know you have to express sin z and cos z in terms of tan z by 2. So dz by, what is tan z? 2 tan z by 2, 1 plus tan square z by 2. Cos z, 1 minus tan square z by 2, 1 plus tan square z by 2 into dz equals to dx. Now, so 1 plus tan square z by 2 is LCM. So it is at the numerator sec square z by 2. So 1 plus tan square z by 2 plus 2 tan z by 2 plus 1 minus tan square z by 2 equals to dx. So this cancel. Now look, it reduces to 2 plus 1 plus tan z by 2 dz equals to dx. So derivative of tan z by 2 is sec square z by 2. So put tan z by 2 equals to p. So sec square z by 2 into half. So to the right hand side it will be 2 dp. So this is 2 dp by 2 into 1 plus p equals to dx. Now it is in standard integration, log 1 plus p equals to x plus c. So log 1 plus, what is p? Tan z by 2 equals to x plus c, which is general solution. Here we have to put z equals to x plus y. So putting some transformation, so it can be reduced to method of separation of variable. So you solve 3 and 4. Now differential, we will discuss solution of differential equation of this form dy by dx equals to a1x plus b1y plus c1, a2x b2y plus c2, where a1 by a2 equals to b1 by b2 not equals to c1 by c2. That is, numerator and denominator, they represent parallel lines. In this case, we also use substitution method. So look, problem number 1 and 2. a1 by a2 half, b1 by b2 half. This is minus 3 by 2, minus 3 by 2. So we have to use transformation, substitution method. So look, this one and this one are parallel lines. So it is obvious that substitution is x plus y equals to z. So we consider problem number 1. Let z equals to x plus y. So dz dx, 1 plus dy dx. So this implies dy dx, dz by dx minus 1. So from 1 and 2, dz dx minus 1, 1 minus 3z by 2z. So dz by dx, 1 minus 3z by 2z plus 1. So 2z is LCM, 1 minus z. So now we have to separate the variable. So 2z dz by 1 minus z equals to dx. So look, here variables are separated. So we have to integrate it. So for problem of this type, numerator and denominator will be of same degree. So we have to use division method or inspection method. So look, 2 outside, we can write it 1 minus z in terms of 1 minus z minus 1 by 1 minus z. So 1 1 cancel, so make it balance by minus dx. So minus 2 dz by 1 minus z cancel. So 1 minus 1 by 1 minus z dz equals to dx. So this is 1 by this cancelled. So now it is simple integration. So minus 2z plus log 1 minus z. This is plus, but 1 minus z, so you get a negative sign. So dz by 1 minus z. So this is log 1 minus z with a negative sign. So this, but minus minus plus. So x plus c. So 2z, 2 into what is z? X plus y. If we transfer it to right hand side, 1 minus x plus y plus x plus c equals to 0, which is general solution. We have to simplify it. 2x plus x, actually it is 3x plus 2y. So final answer is 3x plus 2y. So this is substitution method. Now case 2. Case 2. This is case 1. When b1 equals to minus a2, b1 equals to minus a2, what is our procedure? So look, dy dx equals to three x plus 4y minus 1 minus 4x plus 2y minus 3, 4x minus 5y plus 3, 5x plus y minus 2. So look, so here look, this is b1, b1 equals to minus a. So for this type of problem, to solve this type of problem, we need some results. These results are most important for solving differential equation. So what are the results? You note please. Number 1, d of x plus y. D means differential, so dx plus dy. Number 2, d of x minus y equals to dx minus dy. Number 3, d of xy, x into dy, y into dx. Number 4, d of y by x. So most useful result, x into dy, y into dx. Differential, d of x by y. Similarly, look, this is y square, y into dx, x into dy. So you can write also d tan inverse y by x. So 1 by 1 plus y square by x square, d of y by x. So x square y square is cancelled out, and d of y by x. So x dy minus y dx. So we need this result only for solving this type of equation. So if you recognize this rule, then to solve this type of problem is very simple. Otherwise you have to convert it in terms of homogeneous equation and solve it. So suppose problem number 1. So problem number 1. So after this step, minus 4x plus 2y minus 3 into dy equals to 3x plus 4y minus 1 into dx. So write minus 4x dy, 2y dy, 3 dy. So you expand only 4y dy minus x dx, minus x dx. Now look, we can integrate it, we can integrate it, we can integrate it, we can integrate it. Only 4x dy and 4y dx. So these two terms create problem. So you transfer this term to left hand side or these to right hand side as you please. If we transfer this to right hand side, it will be plus. So write 3x dx. After this 3x dx, this is 3x dx, 2y dy minus 2y dy. It is transferred to right hand side. Then this is 4 common, x dy, y dx. This to be noted when this is transferred to right hand side, 4 common, and this is only 1 dx. So minus dx plus 3 dy equals to 0. So now one more step, 3x dx, 2y dy. This is 4 d of xy. Look, this is d of xy, x dy, y dx. So minus dx plus 3 dy equals to 0. Now you can integrate each term. So if you take integration all term individually, you get 3x square by 2. This is y square by 2 into 2. So y square 4xy minus x 3y plus c dash equals to 0. So multiplying 3x square 2y square 8xy minus 2x plus 6y plus c equals to 0, which is general solution. So listen again. Recognize the problem first. Coefficient of y of the numerator equals to coefficients of x in the denominator with negative sign. Then you just multiply and use this result. So problem number 2. Look, this is minus 5 plus 5. So you try to solve this. Now using these results, so if you try to recall these results, so you can solve this type of problem very easily. So problem number 1, you look. So x dy, y, so this is x dx, y dy. This creates no problem, this creates no problem. Variables are separate. But for this problem, for this part, you look, this is differential of term. So look, d of tan inverse y by x is x dy minus y dx by x square plus y square. So you can write it, look, x dx unchanged. This is y dy. This is d of tan inverse y by x equals to 0. So now look, it is x square by 2, it is y square by 2, this is tan inverse y by x. So take integration this. So this is x square by 2, this is y square by 2. Integration t, so it is eliminated. Tan inverse y by x equals to c, which is general solution. You need these results only. So this equals to differential of tan inverse y by x. For the problem number 2, you look, application. So you can solve it by separation of variable method also. But look, this is y dx x dy. So this is well known result, d of xy, y dx x dy. And this is xy, and this is differential formula of d of x minus y. So now d of xy by xy equals to d of x minus y. Now variables are separated. So dx by x, so you know this is log xy equals to x minus y plus c. So which is general solution. So these are most important results. You can solve many problems of competitive examination if you recall these results by giving least effort. Now we consider method of solving homogeneous differential equation. So what is homogeneous differential equation? We need this definition. So suppose dy dx equals to y into x plus y by x square. Now if we divide by x square, so we get y by x. This is y by x, and this is y by x whole square. So this is v plus v square if y by x equals to v. So this is function of v. So function of y by x. If dy by dx can be expressed as a function of y by x or x by y, then it is called homogeneous. So look it again. If we divide by y square, then dy dx, same equation. So this is x by y whole square, y square. So this is x by y plus 1. So this is f of x by y. So given differential equation can be expressed as a function of x by y. So what is homogeneous differential equation? Definition. A first order, first degree also, differential equation is said to be homogeneous. Said to be homogeneous if dy by dx equals to function of y by x or function of x by y. This is definition. So what is your rule of solving? Rule: put y by x equals to v. So y equals to vx or x equals to vy. So this is rule of solving. So now consider problem number 1. So dy by dx, y by x tan y by x. So this is function of y by x. So it is homogeneous. So rule is put y equals to vx. Then differentiating with respect to x, v into x dv by dx. For it 1. So from 1 and 2. So what is dy dx? V into x dv dx. So y by x is v, this is tan v. So v cancel. So x dv equals to tan v dx. Now separate the variable. Finally you have to separate the variable. So dv by tan v equals to dx by x. So variables are separated. If it is homogeneous, then right hand side is always dx by x if it is function of y by x. So what is chord v? Integration of chord v. This is log sin v equals to log x. So we take integration constant as log c. So log of sin y by x equals to log cx. So sin y by x equals to cx, which is general solution. Which is general solution. So modulus is taken because log this is always positive. You can omit also. In some books it is given as sin y by x equals to c by x. If you omit logarithmic, mod sin x square. So if it is homogeneous, put y equals to dx if function of y by x. If it is function of x by y, put x equals to vy. So consider problem number 5. So look, this is function of x by y. So if it is function of x by y, we calculate dx by dy. So this is dx. So dx by dy equals to, so 1 plus e to the power x by y, and it is to the right hand side. So x by y minus 1 into e to the power x by y. So it is function of x by y. So we calculate. So we put it in the form of dx dy. So let x equals to dy. Then differentiate with respect to y, v plus y dv dy. So this is, so from 1 and 2. So what we are getting, v plus y dv dy equals to 1 plus e to the power v, v minus 1 into e to the power v. So y dv dy, so transfer v to right hand side. So separation of variable is used in each step. So v to the power v minus e to the power v minus v minus v e to the power v. So v to the power v is cancelled out. Now look, you separate the variable 1 plus e to the power v by 1 plus e to the power v by v plus e to the power v into dv equals to minus dy by y. So look, dy to right hand side and this y. So if it is homogeneous, right hand side must be dx by x or dy by y. So this minus is at right hand side. Now look, derivative of this 1 plus e to the power v. So if it is phi x, then it is phi dash x. So log v plus e to the power v equals to minus log y plus log c. Then since this is in terms of log, this is in terms of log, we take integration constant as log c. So log v plus e to the power v by y equals to log of c. So v plus e to the power v by y equals to c. So put value of v. What is v? X by y. E to the power x by y equals to c into mod x by y, which is general solution. We have already stated you can omit logarithm of, modular sign also. So this is method of solving homogeneous differential equation. Today I am solving only basic problems. In the next class I will solve typical types of problem. Next, now we consider method of solving linear differential equation of the form dy dx plus py equals to q, where p and q are function of x or constant. So obviously this is linear, power is 1, p and q are function of x and or constant. So rule is, what is rule? Rule is multiply both sides of 1 by integrating factor. It is written in short if e to the power p dx. So you have to multiply by integrating factor. What is integrating factor? I am discussing later. So consider example 1. Cos square x dy dx plus y equals to 10x. X not equals to pi by 2. Look, 10 pi by 2 is 25. So it is not in standard form. So divide by cos square x. So this implies dy dx plus 1 by cos square x, that is sec square x into y. So this is tan x sec square x. So call it 1. Now what is p? P is sec square x. So if equals to e to the power sec square x dx. So e to the power tan x. So this is integrating factor, e to the power tan x. So multiplying 1 by e to the power tan x, multiplying 1 by e to the power tan x, we get e to the power tan x into dy dx, sec square x into e to the power tan x into y, e to the power tan x into sec square x. Now you look, if we multiply by e to the power tan x integrating factor, the left hand side always can be expressed in the form y into integrating factor. So listen, y dy dx, derivative of y is dy dx, e to the power tan x unchanged. Now y unchanged. What is e to the power tan x? E to the power tan x into sec square x. So left hand side is always expressible in the form d of this. So the term, if we multiply it by e to the power tan x, we can write it left hand side in the form d dx of y into this term. So this term is called integrating factor. Left hand side is expressible in the form of dy dx if we multiply by e to the power tan x. So this term is called integrating factor. Now what advantage we are getting? Look, tan x sec square x dx. So d of this, next step, d of this equals to into dx. We can transfer dx to right hand side. Now here variables are separated. So we can write directly left hand side as d of y into integrating factor. So integrating, so d is eliminated, y into e to the power tan x. Now tan x equals to z. So sec square x dx equals to dz. So it is e to the power z into z dz. So if we integrate it by parts, so what we are getting? This is first function, this is second function, z into e to the power z, z1 e to the power z plus c1. So z e to the power z minus e to the power z plus c1. So finally what we are getting? Look, y into e to the power tan x. So e to the power tan x, e to the power z common, tan x minus 1 plus c or c1. So what is y? Tan x minus 1, c1 into e to the power minus tan x, which is general solution. So rule of solving linear differential equation of this form. So if differential equation is of the form dy dx plus py equals to q, we find integrating factor. Then multiplying by integrating factor, left hand side is y into integrating factor. Then integrate the right hand side. So you solve second and third one. Exactly same type. Now we consider method of solving linear differential equation of the form dx dy. Here dependent variable is x, dx dy plus px equals to q, where p and q are function of y or constant. So exactly same, integrating factor e to the power p dy. So x is replaced by y. So consider problem number 1. So what is dy by dx? So this is y by 10y cube minus 2x. So it is not separate. This x and y are in mixed form. We cannot solve it by separation of variable. You cannot solve it by substitution method. This is also not homogeneous. So if you write it as dx by dy, then look, you can write it in this form. It can be written as 10y square. So dx dy plus 2y into x equals to 10y square. Now look, initially it is not in standard form. Now you can put it in the standard form. So here variable y is replaced by x. So what is integrating factor? E to the power 2 by y dy. So e to the power 2 log y. So e to the power log y square. So this is y square. So integrating factor is y square. So if we know the integrating factor, so what is left hand side? Therefore 1. This is 1 implies left hand side will be d dy of x into integrating factor. It is of second type, not y. X into integrating factor. And what is right hand side? Right hand side is 10y square. 10y square into y square. 10y to the power 4. So d of x of y square. 10y to the power 4 dy. So now variables are separated. So this is x into y square equals to y to the power 5 by 5. So 2 plus 3, which is general. So this is most important problem. So if it is not of the form dy by dx, we take reciprocal. So consider last problem, problem number 3. So look, in general, we write the problem in this form, dy by dx. What is dy by dx? So 1 plus y square, tan inverse x minus x. So this is only function of y. So we cannot write it as two parts. So that is why it is tan inverse x minus x by 1 plus y square. Then dx by dy, 1 by 1 plus y square into x. So I think this one is wrong. This is tan inverse y. So you correct it. This is tan inverse y. Sorry, this is tan inverse y. Now look, this is in standard form. So it is in standard form. What is integrating factor? E to the power p dy. X is replaced by y. So e to the power tan inverse y. So tan inverse y to the power. So 1 implies d dy of, not d dx, d dy of x into integrating factor. Right hand side, tan inverse y by 1 plus y square unchanged, e to the power tan inverse y. So now it is separation of variable. Tan inverse y by 1 plus y square, e to the power tan inverse y dy. So take integration. Now if we put tan inverse y as z, so 1 by 1 plus y square into dy equals to dz. So this implies x into e to the power tan inverse y. So z e to the power z dz. And we have already solved this problem by parts. So put the value e to the power z. What is z? Tan inverse y. Tan inverse y minus 1 plus c. So x into e to the power x. So if you divide, then tan inverse y minus 1 c into e to the power tan inverse y, which is general solution. This is also most important problem for competition also. So today we have solved different methods. We have discussed different methods of solving differential equation. Method of separation of variable, method of substitution, homogeneous differential equation, linear differential equation dy dx plus py equals to q, and dx dy plus px equals to q. So we have solved different methods of solving differential equation. Today we have considered only simple problem. These are basic concept only. From next class we will solve difficult and typical problem of differential equation.